Dear students, let's start a new topic. Electrolysis of acidified water using platinum electrodes. This topic from chapter 6 of class 10th in subject chemistry. Let's open your chemistry book and come on the page number 120. Now the topic is electrolysis of acidified water using platinum electrodes. So as you know that pure water does not conduct the electricity because their degree of ionization is very low. But whenever we add some dilute sulfuric acid to the water, then water become a good conductor of the electricity, and this water is called the acidified water or acidulated water. The acidified water or acidulated water is used for the electrolysis by using the platinum electrodes. So the electrolysis of acidified water, we can use a special type of electrolytic cells. That electrolytic cell is called the Hofmann apparatus. Now here the diagram showing the apparatus, the Hofmann apparatus. Now this Hofmann apparatus consists of three limbs. These limbs containing acidified water or dilute H2SO4. This acidified water or dilute H2SO4 behave as a electrolyte. Now two platinum foil taken as electrodes. One platinum foil behave as a anodes and another platinum foil behave as a cathodes in two other limbs. When this platinum foils connected with the positive terminal of the battery, then it behave as a anodes. When this platinum foil connected with the negative terminal of a battery, then it behave as a cathode. So the electrodes are made up of platinum foils. Anode or cathode, both electrodes are made up of the platinum foils. When the electric current passes through the acidified water, when switch is on, then electric current passes through the acidified water. Then acidified water get dissociated into their respective ions, and the electrolysis will take in place. As you can see that the electrolysis of the acidified water. Now the sulfuric acid, from the sulfuric acid, the H plus ion and SO4 ion dissociated from the sulfuric acid, and H2O dissociated into water, dissociated into H plus and OH minus ions. Now the H plus ions migrate towards the cathode electrodes, and both the sulfate ion and hydroxyl ion both migrate towards the anode electrodes, and the ions get discharged at their respective electrodes. So the reaction at the cathodes, only H plus ions migrate towards the cathodes and they get discharged. So H plus ions taken 1 electrons from the cathode electrode, and it form atom of hydrogens. Now the two atom of hydrogens combined to each other to forms a molecule of the hydrogen at the cathode. Now the reaction at anode, both sulfate ion and hydroxyl ion migrates towards the anode, but hydroxyl ion get discharged in preference to the sulfate ion, because hydroxyl ion placed lower in the electrochemical series than sulfate ion. So the hydroxyl ions preferentially get discharged to the sulfate ion. So at the anode, both ion migrate, but only hydroxyl ion get discharged. Hydroxyl ions loses their electron to the anode and forms the H2O and oxygen, water and oxygen. In the primary reaction, now oxygen is collected at the anode by displacing the liquid in the voltmeter, and hydrogen, so at the anode oxygen collected by displacing their acidified water, and hydrogen collected in the Hofmann voltmeter by displacing the sulfuric acid, diluted sulfuric acid in the cathode. Now, what is the applications of electrolysis of acidulated water? Electrolysis of acidulated water is used in the production of pure hydrogen and oxygen. Okay.